The National Electrical Code, or NEC, doesn't explicitly state a maximum length for conductors connecting a transient voltage surge suppressor, or TVSS, to the line or bus and to ground. However, NEC 110.3b lays out general requirements stating that electrical installations must be neat and workmanlike and installed in a workmanlike manner. This implies that the conductors should be installed in a safe and professional manner, avoiding potential hazards. Shorter conductors are generally preferred because they have less resistance. Low resistance allows for more efficient current flow. Shorter conductors are also less prone to damage and reduce the risk of fire hazards. There may be situations where longer conductors are needed, for example, when the TVSS is located far from the electrical panel. In these instances, extra care is needed to ensure safe and correct installation. Here are some guidelines for installing conductors that connect the TVSS to the line, bus, and ground. 1. The conductors should be rated for the maximum current the TVSS can handle. 2. The conductors should be installed in a conduit or another approved raceway. 3. The conductors must be securely terminated at both ends. 4. The conductors should be protected from physical damage like pinching or crushing. Firstly, ensure the conductor's ampacity rating meets or exceeds the TVSS maximum surge current rating. This information is usually found on the TVSS's nameplate. Selecting the correct wire size is crucial for safety and performance. Using undersized conductors can lead to overheating and potentially cause a fire. Secondly, always use conduit or an approved raceway to protect the conductors. Common raceway types include electrical metallic tubing, or IMT, rigid metal conduit, or RMC, and flexible metal conduit, or FMC. The choice of raceway depends on the specific application and environmental conditions. For example, RMC is suitable for harsh environments, while EMT is commonly used indoors. Thirdly, secure terminations are vital for a reliable and safe installation. Use appropriate connectors and tighten them to the manufacturer's specified torque. Poor terminations can cause loose connections, leading to arcing, overheating, and potential fire hazards. Regularly inspect terminations to ensure they remain tight and free of corrosion. Fourthly, protect the conductors from physical damage. Avoid running conductors in areas where they could be pinched, crushed, or exposed to sharp objects. If conductors must pass through walls or floors, use appropriate bushings or grommets to prevent abrasion. Also, protect conductors from exposure to chemicals, moisture, and extreme temperatures. Remember that minimizing conductor length is generally beneficial for TVSS performance. Shorter conductors offer lower impedance, which allows the TVSS to respond more quickly to voltage surges. This faster response time can provide better protection for sensitive electronic equipment. While there is no specific maximum length defined by the NEC, good engineering practice suggests keeping conductors as short as practically possible. When longer conductors are unavoidable, consider using larger gauge conductors to reduce impedance and voltage drop. In addition to the physical installation of the conductors, proper grounding is crucial for effective surge protection. The grounding conductor should be as short and direct as possible, connecting the TVSS to the building's grounding electrode system. A poor ground connection can significantly reduce the effectiveness of the TVSS and may even create a safety hazard. Regularly inspect the grounding system to ensure it's in good condition and free of corrosion. Furthermore, proper bonding is important to minimize voltage differences between different parts of the electrical system. Bonding involves connecting all metallic components, such as conduits, enclosures, and equipment frames to the grounding system. This helps to create an equipotential plane, reducing the risk of electrical shock and improving the effectiveness of surge protection. Always follow the manufacturer's instructions when installing a TVSS. The manufacturer's instructions provide specific guidance on conductor sizing, termination methods, and grounding requirements. Ignoring the manufacturer's instructions can void the warranty and may compromise the safety and performance of the TVSS. When selecting a TVSS, consider the voltage rating, surge current capacity, and protection mode. The voltage rating should match the voltage of the electrical system. The The surge current capacity indicates the maximum surge current the TVSS can handle. The protection mode refers to the types of surges the TVSS can protect against, such as line-to-line, line-to-neutral, and line-to-ground surges. Regular maintenance is essential for ensuring the continued effectiveness of a TVSS. Periodically inspect the TVSS for signs of damage, such as discoloration, swelling, or cracking. Also, check the indicator lights to ensure the TVSS is functioning properly. Replace the TVSS if it shows any signs of damage or if the indicator lights indicate a problem. Remember to de-energize the circuit before performing any maintenance on the TVSS. Always use appropriate personal protective equipment, or PPE, such as safety glasses and gloves, when working with electrical equipment. Working with electricity can be dangerous, so it's important to take precautions to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician to install and maintain the TVSS. A qualified electrician has the knowledge, skills, and experience to safely and correctly install and maintain electrical equipment. In summary, while the NEC doesn't specify a maximum length for TVSS conductors, shorter conductors are generally better for performance and safety. Follow the guidelines outlined above to ensure that the conductors are installed safely and properly. Remember to consult the manufacturer's instructions and to hire a qualified electrician if you are not comfortable working with electricity. Keep in mind NEC 110.3. B for neat and workmanlike installations. It is also important to note that the recommendations provided here are general guidelines and may not be applicable to all situations. Always consult with a qualified electrical engineer or inspector to ensure that the TVSS is installed in accordance with all applicable codes and standards. Proper surge protection is crucial for protecting sensitive electronic equipment from damage caused by voltage surges. By following these guidelines, you can help to ensure that your equipment is protected and that your electrical system is safe. It's also worth noting that surge protection is not just for expensive electronic equipment. Even seemingly simple appliances like refrigerators and washing machines can be damaged by voltage surges. Consider installing surge protection devices throughout your home or business to protect all of your electrical equipment. There are different types of surge protection devices available, including whole house surge protectors and point-of-view surge protectors. Whole house surge protectors are installed at the main electrical panel and provide protection for the entire electrical system. Point-of-view surge protectors are plugged into individual outlets and provide protection for specific devices. The best approach is to use a combination of both whole house and point-of-view surge protectors. This provides comprehensive protection for all of your electrical equipment. In addition to surge protection, it's also important to have a good grounding system. A good grounding system helps to dissipate voltage surges and protect against electrical shock. Make sure your grounding system is properly installed and maintained. Regularly inspect the grounding system for signs of corrosion or damage. If you find any problems, have them repaired immediately. Also, be aware of the signs of a voltage surge. These signs may include flickering lights, power outages, and damaged electronic equipment. If you suspect that you have experienced a voltage surge, have your electrical system inspected by a qualified electrician. A qualified electrician can identify any damage and make the necessary repairs. Finally, remember that surge protection is an ongoing process. As technology changes and new threats emerge, it's important to stay informed and to update your surge protection system as needed. By taking these steps, you can help to protect your electronic equipment from damage caused by voltage surges. Remember, a proactive approach to surge protection is the best way to ensure the safety and reliability of your electrical system. Furthermore, always consult with local authorities and adhere to any specific regulations or requirements in your area regarding electrical installations and surge protection. Local codes may have specific requirements that go beyond the NEC, and it's crucial to comply with those regulations to ensure safety and legal compliance. Proper documentation is also important for electrical installations, including TVSS installations. Keep records of all inspections, maintenance, and repairs performed on the electrical system and surge protection devices. This documentation can be helpful for troubleshooting problems and for demonstrating compliance with code and standards. When selecting electrical components such as conductors, conduits, and surge protection devices, choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, Oral, or Intertech, or ETL. Listing and labeling indicate that the products have been tested and meet safety standards. Avoid using counterfeit or unapproved electrical components, as they may not meet safety standards and could pose a fire or shock hazard. In addition to protecting against voltage surges, it's also important to protect against other electrical hazards, such as ground faults and arc faults. Ground fault circuit interrupters, or GFCIs, protect against ground faults, which can cause electrical shock. Arc fault circuit interrupters, or FCIs, protect against arc faults, which can cause fires. Consider installing GFCIs and FCIs in your home or business to provide additional protection against electrical hazards. By addressing all of these aspects of electrical safety, you can create a safer environment for yourself, your family, and your employees. Electrical safety is an ongoing responsibility, and it's important to stay vigilant and to take steps to protect yourself from electrical hazards. Finally, never attempt to perform electrical work if you are not qualified to do so. Electrical work can be dangerous, and it's always best to hire a qualified electrician to perform any electrical work. A qualified electrician has the knowledge, skills, and experience to safely and correctly install and maintain electrical equipment. Remember that electrical safety is not just a matter of following codes and standards. It's also a matter of common sense. Be aware of the potential hazards of electricity and take steps to protect yourself from those hazards. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. Additionally, consider the impact of harmonics on your electrical system. Harmonics are distortions of the sinusoidal waveform of alternating current, or AC, electricity. Harmonics can be caused by nonlinear loads, such as electronic devices and variable frequency drives, or VFDs. Harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with electronic devices. If you suspect that you have harmonics in your electrical system, have it tested by a qualified electrician. There are various ways to mitigate harmonics, such as using harmonic filters and reactors. A qualified electrician can recommend the best solution for your specific situation. Also, be aware of the potential for electromagnetic interference, or EMI. EMI is unwanted electrical energy that can interfere with the operation of electronic devices. EMI can be caused by a variety of sources, such as radio transmitters, cell phones, and electrical equipment. To minimize EMI, use shielded cables and enclosures, and keep electronic devices away from sources of EMI. In addition, consider the effects of voltage sags and swells on your electrical system. Voltage sags are temporary reductions in voltage, while voltage swells are temporary increases in voltage. Voltage sags and swells can be caused by a variety of factors, such as changes in load, faults in the electrical system, and weather events. Voltage sags and swells can damage electronic equipment and cause it to malfunction. To protect against voltage sags and swells, use voltage regulators and uninterruptible power supplies, or UPSs. A voltage regulator maintains a constant voltage output, while a UPS provides backup power in the event of a power outage. In conclusion, maintaining a safe and reliable electrical system requires a comprehensive approach that addresses all potential hazards and disturbances. By following these guidelines and consulting with qualified professionals, you can ensure that your electrical system is protected and that your equipment operates safely and efficiently. Remember, electrical safety is an ongoing process that requires vigilance and attention to detail. By staying informed and taking proactive measures, you can protect yourself, your family, and your property from the dangers of electricity. These considerations are essential for ensuring a safe and reliable electrical environment in any residential, commercial, or industrial setting.